Syslog is a standard for computer message logging. It permits separation of the software that generates messages from the system that stores them and the software that reports and analyzes them. Syslog can be used for computer system management and security auditing as well as generalized informational, analysis, and debugging messages. It is supported by a wide variety of devices and receivers across multiple platforms. Because of this, Syslog can be used to integrate log data from many different types of systems into a central repository. Messages are labeled with a facility code indicating the type of software that generated the messages, and are assigned a severity. Implementations are available for many operating systems. Specific configuration may permit directing messages to various devices, files or remote Syslog servers. Most implementations also provide a command line utility, often called logger, that can send messages to the Syslog. Some implementations permit the filtering and display of Syslog messages. Syslog is now standardized by the IETF and RFC 5424. History: Syslog was developed in the 1980s by Eric Ullman as part of the SendMail project, and was initially used solely for SendMail. It proved so valuable that other applications began using it as well. Syslog has since become the standard logging solution on Unix and Unix-like systems. There have also been a variety of Syslog implementations on other operating systems and is commonly found in network devices such as routers. Syslog functioned as a de facto standard, without any authoritative published specification, and many implementations existed, some of which were incompatible. The Internet Engineering Task Force documented the status quo in RFC 3164. It was made obsolete by subsequent additions in RFC 5424. At different points in time, various companies have attempted patent claims on Syslog. This had little effect on the use and standardization of the protocol. Outlook: various groups are working on draft standards detailing the use of Syslog for more than just network and security event logging, such as its proposed application within the healthcare environment. Regulations, such as SOX, PCI DSS, HIPAA, and many others are requiring organizations to implement comprehensive security measures, which often include collecting and analyzing logs from many different sources. Syslog has proven to be an effective format to consolidate logs, as there are many open-source and proprietary tools for reporting and analysis. Converters exist from Windows Event Log as well as other log formats to Syslog. An emerging area of managed security services is the collection and analysis of Syslog records for organizations. Companies calling themselves managed security service providers attempt to apply analytics techniques to detect patterns and alert customers to problems. Facility levels: a facility level is used to specify what type of program is logging the message. This lets the configuration file specify that messages from different facilities will be handled differently. The list of facilities available, the mapping between facility number and keyword is not uniform over different operating systems and different Syslog implementations. For cron either 9 or 15 or both may be used. The confusion is even greater regarding auth-priv. 4 and 10 are most common but 13th and 14th may also be used. Severity levels: RFC 5424 defines 8 severity levels. A common mnemonic used to remember the Syslog levels from bottom to top is, "Do I notice when evenings come around early?" Format of a Syslog packet: the full format of a Syslog message seen on the wire has 3 distinct parts. PRI header MSG. The total length of the packet cannot exceed 1024 bytes, and there is no minimum length. Priority: the PRI part is a number that is enclosed in angle brackets. This represents both the facility and severity of the message. This number is an 8-bit number. The first 3 least significant bits represent the severity of the message and the other 5 bits represent the facility of the message. You can use the facility and the severity values to apply certain filters on the events in the Syslog daemon. Calculating priority value: the priority value is calculated by first multiplying the facility number by 8 and then adding the numerical value of the severity. For example, A kernel message with a severity of emergency would have a priority value of 0. Also, a local use-for message with a severity of notice would have a priority value of 165. In the PRI part of a syslog message, these values would be placed between the angle brackets as less than 0, and less than 165, respectively. Calculating facility and severity values from a priority value. This is a calculation derived from the previous one. To get the facility number implied in a given priority value, divide the priority number by 8. The whole number part is the facility. To get the severity, multiply the facility by 8 and subtract that number from the priority. For example, priority equals 191 and 191/8 equals 23.875, facility equals 23, severity equals 191 equals 7. Work backward to check the formula. 23 times 8 equals 184 plus 7 equals 191. Header. The header part contains the following: timestamp, the date and time at which the message was generated. This is picked up from the sending system's system time, which might differ from the receiving system's system time, hostname or IP address of the device. Message. The MSG part will fill the remainder of the syslog packet. This will usually contain some additional information of the process that generated the message, and then the text of the message. The MSG part has two fields: TAG field, content field. The value in the TAG field will be the name of the program or process that generated the message. The content contains the details of the message. Limitations. The UDP-based syslog protocol is unreliable. Unlike TCP-based transmission of messages, UDP does not guarantee you the delivery of the messages. They may either be dropped through network congestion, or they may be maliciously intercepted and discarded. The Syslog protocol does not ensure ordered delivery of packets. Since each process, application and operating system was written independently, there is little uniformity to the content of Syslog messages. For this reason, no assumption is made upon the formatting or contents of the messages. The protocol is simply designed to transport these messages. The receiver of a Syslog packet may not be able to authenticate that the message was indeed sent from the reported sender. A misconfigured machine may send syslog messages to a syslog daemon representing itself as another machine. The administrative staff may become confused because the status of the supposed sender of the messages may not be accurately reflected in the received messages. Another problem associated with authentication is that an attacker may start sending fake messages indicating a problem on some machine. This may get the attention of the system administrators, who will spend their time investigating the alleged problem. During this time, the attacker may be able to compromise a different machine, or a different process on the same machine. An attacker may record a set of messages that indicate normal activity of a machine. At a later time, that attacker may remove that machine from the network and replay the syslog messages to the daemon. Protocol. Syslog is a client-server protocol. A logging application transmits a text message to the syslog receiver. The receiver is commonly called syslogged, syslog daemon or syslog server. Syslog messages may be sent via the user datagram protocol or the transmission control protocol. The data is sent in clear text. Although not part of the syslog protocol itself, an SSL wrapper may be used to provide for a layer of encryption through SSL/TLS. Syslog uses the port number 514. The original specification in RFC 3164 did not specify many protocol aspects, such as the maximum message size and the character encoding for the message text. RFC 5424 added many details. Among others, implementations must support a maximum message size of at least 480 octets, and should support 2048 octets. Messages should be encoded as UTF-8. Internet standards. The Syslog protocol is defined by request for comments documents published by the Internet Engineering Task Force. The following is a list of RFCs that define the Syslog protocol: RFC 3164, the BSD Syslog protocol, RFC 3195, reliable delivery for Syslog, RFC 5424, the Syslog protocol, RFC 5425 TLS transport mapping for Syslog, RFC 5426 transmission of Syslog messages over UDP, RFC 5427 textual conventions for Syslog management, RFC 5848 sign Syslog messages, RFC 6012 datagram transport layer security transport mapping for Syslog, RFC 6587 transmission of Syslog messages over TCP, C. Also. References. External links, IETF Syslog Working Group, SANS paper The Ins and Outs of System Logging Using Syslog, NIST SP 800-92 Guide to Computer Security Log Management, NetLogger Methodology and Tools for Debugging and Analysis of Complex Distributed Applications.